So we have these problems here that we're going to take a look at. This is what you should have got from the problems that you did on the board. So remember that anything raised to the 0 power is 1. Anything to the first power is just itself. This is our quick pattern that we found out about the other day, where you square the first, square the last, double the product. And then to get cubed, we would take this and times it by x plus 1, which ends up giving us this. And then to get x to the fourth, we can either multiply this by x plus 1 or multiply this by itself. So you could also take this and use the other pattern that we had when you're squaring a trinomial, and square this, square this, square this, twice this product, twice this product, twice this product. And then that would give you the same answer as well. So if we take a look at this, if we look at the coefficients that we have for all of these, so on our first one we have 1. On our second one we have 1 and 1. On our third one down we have 1, 2, and then 1. And our third one, or our fourth one down, we have 1, 3, 3, and 1. And then our last one we have 1, 4, 6, 4, 1. So these are our coefficients that we have from raising x plus 1 to 0, 1, 2, 3, and 4. Okay. Now this pattern that we've created right here, it has a special name. We call it Pascal's triangle. So the way that you can create Pascal's triangles, it starts with a 1, and then you have 2 1s, and then after that each row starts with 1, and then you find this sum. So 1 plus 1 is 2, and then when you're out of things to add, you end with a 1. So I start with a 1, 1 plus 2 is 3, 2 plus 1 is 3, end with a 1. Start with a 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, end with a 1. Start with a 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and you end with a 1. Okay. Now in Pascal's triangle, we take a look here and we start counting. Notice our powers that we had started with 0. So this row we count as row 0, this is row 1, this is row 2, row 3, row 4, row 5, and so on and so forth. So notice the second number in is the same row number. So this is 1, 2, 3, 4, 5. So whatever your second number is what row you are in. Okay. So if we were to say what's x plus 1 to the 5th power, we would have these coefficients of 1, 5, 10, 10, 5, 1. So if we look at our pattern for the variables, notice this one didn't have a variable. Then we had an x to the first power and then no variable. Then we had an x squared, x, and no variable. X cubed, x squared, x, no variable. X to the fourth, x cubed, x squared, x, and then no variable. So our variable starts at the highest power of whatever power we're raising it to, and then it goes in descending order from there. So this would be, since we're to the 5th, be x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and really this would be x to the 0, but remember anything to the 0 power is 1, so it would really just be 1 times 1, which is really just 1. Okay, and then don't forget that you would have addition signs in between here. Okay, so we can use Pascal's triangle and this pattern that we found to raise things to powers that are higher numbers. So we can use this to our advantage. Now, if I wanted to do x plus 5 squared, now on this one, if we take our pattern, I would, not squared, let's do to the 4th, sorry. X plus 5 to the 4th. So if I do this one, I'm going to have my first pattern of x to the fourth. Then I'm going to go down, x cubed. Notice I'm leaving space for my numbers I'm going to have later. X squared, x to the first, and then x to the 0. Now, notice in all of these, this was just 1. So if we look at the ones, our pattern for the ones doesn't show up here because of what happens when you raise 1 to any power. If I raise 1 to any power, I get 1. Okay. Now, since this is something other than 1, we're going to have another pattern that happens. So with this, we're going to start at 5, and instead of starting at the 4th power, I'm going to raise it to the 0 power, and then instead of counting down like these ones did, these ones are going to count up. So it's going to be 5 to the first, 5 to the second, 5 to the third, and 5 to the fourth. Okay. Then these coefficients, so this is to the 4th power, so I'm going to go to my 4th row starting at 0. So 0, 1, 2, 3, 4. Notice my second number matches the power that I have, so my coefficients are going to be 1, 4, 6, 4, 1. So now I'm just going to evaluate this. So 5 to the 0 is 1, so I have 1 times x to the 4th, which is really just x to the 4th. Here I have 5 to the first, which is 5, so I have 4 times 5 times x cubed, which is really 20x cubed. 5 squared is 25, so I have 6 times 25 times x squared. So if I do 6 times 25, that gives us 150. I really have 150x squared. Then I have 5 cubed, which is 125, so plus 4 times 125 times by x. So if I do 4 times by 125, I get 500, so plus 500x, and then plus 1 times x to the 0 is 1, times 5 to the 4th, which is 625. So rather than do like what you guys did and take a lot of time to find out what this is, I can use this Pascal's triangle and the pattern of the x's starting with the highest power and descending, so to the 4th, 3rd, squared, 1, none, and then using our coefficients from Pascal's triangle, so 1, 4, 6, 4, 1, since we're in the 4th power. And then because this number is something other than 1, we're going to start by raising this to the 0 power and then count up. So 0, 1, 2, 3, 4. And then we just evaluate to find out what the answer is. So it becomes quicker to do this with what we call the binomial theorem than to multiply it out by hand. Now, if you take a look at a calculator, and if you were to do, remember when we did combinations? So if we do 5 combination 0, not 5, 4. 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, and 4 combination 4. If you do those on your calculator right now, let's see what you get as your numbers. So pause the movie for a second and then find your combinations. Now, if you can't remember where to find your combinations on your calculator, you go to Math, then see the PRB, so you're going to go over to Probability, and you want Combination, which is the last one. Now, I forgot to put my number in front, so I need 4, and then you would do Math, Combination, and then 0. So now try the rest of them. Okay, so you should have the rest of them, so if we quickly look at those numbers, we have 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. So, notice the numbers that we got were 1, 4, 6, 4, 1. Well, what are these numbers? Well, that's this row right here. So not only can I find these numbers by using Pascal's triangle, I can also use combinations instead to find out what these numbers are instead of creating a whole Pascal's triangle. Okay? So if I had something raised to a really high power like 22, it might be more advantageous to use combinations as opposed to make 22 rows of Pascal's triangle. So that's another thing that you can do. And notice on your homework it says that on the evens you're to do one of them and the odds you're to do the other. So one you're going to do combinations and one you're going to do using Pascal's triangle. Okay? So if I were going to use combinations, instead of having a 1 here, I would put this here. Instead of having a 4, I'd put this here first, the combination, and then say that it was 4. And then I put this where the 6 is, this where the 4 is, and this where the 1 is. Okay. Now, let's take a look at what happens when you have a minus. So notice all of these were x plus a number, and this was also x plus a number. Let's take a look at what happens when you have x minus a number. So